Hello, myself Dr. Nimesh Chaturvedi, and I am going to discuss frequent pattern and association rule mining techniques. I am currently working as assistant professor at IIIT Dharwad in data science and AI department. So, what is frequent patterns? Frequent patterns are basically item sets or subsequence or substructure that are continuously reappearing on the database. Then we'll define item sets like I1, I2, up to IM. So I could be items like bread, butter, jam in retail market basket, or it could be medicine in healthcare like medicine one, medicine two, and so on. So we'll discuss three algorithm mining algorithms: a priori algorithm, FP growth, and parallel FP growth. So there's a priori algorithm that's I1, I2 are the set of literals of items. We'll discuss is support of rule X implies Y. What is X implies Y? If set X items are appearing, then most probably Y items are also going to appear with a significant support and confidence. So there's a confidence. What is confidence? If X is appearing, then Y will also appear. That is how much percentage confidence is there. So we'll put threshold, minimum support, and minimum confidence, and we'll generate rules. Starting with the support, like what is support count? Like just count how many time X union Y is appearing, and we just have to calculate X union Y. So if you see, bread and peanut are appearing one time, two time, and three times. So bread and peanut butter is appearing three times out of five transactions. And if you just want to calculate how many times bread is appearing, it is appearing four times. So bread is appearing uh, as antecedent. So there is a four, and there's peanut bread and peanut butter is appearing three times both together. So it will be 3 by 4, which is actually 75%. If you calculate peanut butter and bread, it will be same as 3 by 5 because three times both are occurring out of five transactions. But here you see peanut butter is appearing only three times. Peanut butter is appearing only three times, which is actually conditional probability such that X is already appeared. Then we have to calculate the occurrence of both of them. Then beer and bread, it is basically 1 by 5 by beer is appearing, beer and bread is appearing only one time together, and it is 1 by 2 as the confidence. Peanut butter and jelly, if you calculate, it will be appearing only one time, peanut butter and jelly. This is first transaction it contains. So just 1 by 5. And if you see, it is basically 1 by 3. Like peanut butter is appearing three times, we already calculated. And jelly and peanut butter, if you calculate again 1 by 5. But here the confidence would be 1 by 1 because jelly is appearing only one time. And jelly and milk is never appearing. So it's have support and confidence 0. Now, if you put a threshold like minimum support, so at least it has to be 60% support, and so that we'll consider that rule as interesting. It has to be at least 75% of minimum confidence, so that we'll consider it as uh, significant rule. So if we put this type of threshold like 75% as minimum confidence and 60% as minimum support. So we'll get only two rules. Bread implies peanut butter and peanut butter implies bread. Support is 60% and confidence is 75%. So if you see, these two rules are significant and interesting. These two meet the criteria of thresholds. Next, we have a FP tree generation. This is another method to create frequent pattern tree. So we use support threshold as 3. So for this given database, here the database is changed. So in this database, what are the frequent items? F is appearing one time, two time, three time, and fourth time. So F is basically above 3. So F is significant. Then you calculate for A is appearing 1, 2, 3 times. So A is also frequent. If you calculate C 1, 2, 3, so it is basically 3 times. Again, C is actually uh, having frequent items and so on. Then if you have root, so F, C, A, M, and P are being this in from the first transaction, and from the second transaction you just have to increment F by 1, C by 2, A by 2, and you just create this uh, branch B and M. Then thereafter you just have to make one branch from F to B and increment F by 1. Then you have another branch to be added C, P, and M. Then you just have to, for the fifth transaction, F is incremented by 1, becomes 4, and C will be incremented by 1, it will become 3, and A will be incremented by 3 and M is incremented by 3 and P is also incremented by 3. So it will basically, we have created FP tree based upon calculating frequency of each item set and then we encode it as a tree and we will extract frequent items can be extracted from the FP tree and from this transaction, we can create rules like F implies C, C implies A, and so on. So as a pointer, F has uh, this pointer to F, and you will see this. So C is also behaving like a pointer, and you will have the C pointer, which is actually then A pointers, B pointer, and so on. So there's a parallel version of this scalable version of FP growth, which is implemented on a Spark ML lib. And there's a Spark ML lib, which is actually having distributed computing environment for parallel computing. It creates FP3 for the large or big data, and it is basically scalable, which can run on single machine as well as it can be executable on distributed computing. Suppose there are 8 cores on your simple laptop or computing machine, so all 8 cores could be utilized using this Spark computing, and that will be efficient way of computation. So it will execute it as an independent group for mining tasks. It is basically started and worked by Google Research Lab. So it's one of the Google Research. How it works? So you just write a map function for these same example that we discussed earlier. So transactions. So find out what are the frequent items and eliminate infrequent item. You'll get F, C, a, M, and P as the frequent items, and then you'll eliminate for the second transaction also you'll eliminate some of the infrequent items, and you'll get only frequent item. What are the frequent item? F, C, A, B, M. What are the frequent items in third transaction? F and P. We have already discussed this. So we just put a sequence like here. So if you see P, M, A, and C. So if P is appearing, then F, C, A, M are appearing uh, before P. F, C, A is appearing before M. So there is a simple sequence which has been arranged. Similarly, for the second transaction here, if we want to make a pair like reduce function, we'll write for P, we'll get this sequence for then we'll get a p value like this. Similarly, we'll get for m. M is also like appearing in multiple transactions and so on. So we'll get this type of reduce function results. Thereafter, if we just want to generate a conditional FP tree based upon how many times C is appearing, it is one, two, three. C is significant, but is F is significant? No, F is appearing only two times. Means we just reject F and we just get C as the three items. So A is also rejected, B is also. This will create C implies P as the uh, rule. Here, F, C, and A all are appearing three times. So it will create F implies M, and C implies M, and A implies M like rule. And so on. You will calculate for this also in the same way. The next, this is pre-implemented in Spark. So you just have to mention minimum support and minimum confidence. What is minimum support? We already discussed. We want at least 3 out of 6 transactions should consist means 50%. What is 50%? It is 0.5. Then we want a confidence of 0.6%, means 0.6, that is 60%. So 0.6 fraction of, then if we have 8 core machine, then we'll put simple number of partition that we want. And uh, as a result, it will generate frequent items and association rule. So frequent items are basically items in array, and then frequent uh, result. Then thereafter, association rules are there. Antecedent and consequence are being arranged along with the confidence. Then uh, you'll get a code like this to run a. So this is a simple code for 3 transactions. So 3 transactions are there. Each of the transaction items are splitted with a space. Thereafter, it will create a schema. That is schema basically use named it as items for each of the strings which is separated by space, and it will create item frame. So this schema is used for creating item frames, and this item frame is further used for mining purpose. And this model is already been implemented. This what we discussed, map reduce, is already pre-implemented. You just have to put the name of that items, that is items, and then 0.5 threshold or zero point 0.6 as confidence value, and then you will get displayed a frequent item sets or frequent association rules, and you'll get all the data result as a summarized form. So these are the results that are being generated. Thanks. This is belonging to some uh, machine learning or data mining topic, as well as it could be like in big data analytic tools and techniques. I used to cover machine learning data mining topics, and I used to also teach Spark, Hadoop framework, or parallel computing, distributed computing, mining algorithms, or machine learning.